Hope my screen is visible. My screen is visible. So last class, we discussed the sample. What is meant by sample? Uh, Let me give a few examples related to sample. Sample is representing the total population. So sample is representing the total population. In manufacturing company, if you take example of medicine, if you take example of soaps, if you take example of any product, there are mass production is going on in factories. In the mass production, what they'll do, quality section will be there. They'll check randomly, hourly ones, or else cartoon basis, or else shift basis. They'll take the sample and they'll test the quality. Let me give few examples related to this sample. Okay. Let me give few examples. Once you entered into petrol pumps, petrol oil tank is came to pump and loaded into their place. In that, after that, they'll take 1 liter of petrol. In that, they'll test quality test. So even if you want to test in petrol pump, so there is a provision, they'll give one kind of paper where you can test the purity of the petrol if you want. The quality matters. So similarly, if you go to sugar factory, in sugar factory, they'll test the different phases. They'll test the different phases and different process of the making of the sugar, starting from raw material to finishing product. Even if you take like a soap manufacturing company, they'll take some sample and they are going to fix the quality of the product. So sample is nothing but it's a portion of okay uh, population in here. So capital N and small n, capital N and small n. What is meant by capital N? What is meant by small n? So what is meant by capital N and what is meant by small n? So here capital N denotes total population. Okay, capital N denotes total population, whereas small n denotes sample size. Okay. In even you can understand this kind of thing. I'm going to give one more real example related to our real life world. So now season is like watermelon season. If you want, no, one seller, watermelon seller stating that, so this watermelon is so sweet. Then what you lost in our local languages, taka, taka. So give some taka. So they'll cut it in square or rectangle shape, whatever shape. So they'll cut the piece. They insert some hole for that. So and he shows that. So color is red. If you want to taste it, then he cut it some piece and he can taste. You can taste. Okay, it's a sweet like that. So here accepting sample here. Okay. Now, accepting sample. What is meant by accepting sample? So here, so sample inspection is a screening mechanism used to separate acceptable products from product of poor quality. Why we need to do sample? Product we can classify it into poor quality, great quality, worst quality, whatever it may be. So we need to inspect that. So we need to check the poor quality products. Poor quality products. Number one. Okay, so here sampling poor quality, it actually does not improve the quality, of any product. The most observed way to tell whether the product items acceptable or not. Acceptable or not. One second. Yes. So here, it most of the whether the product will be acceptable or not. So it done every item, 100% inspection is performed. There would be no need of use acceptable sampling. Sometimes we need to go with 100% sampling. So 100% inspection is performed. There would be no inspection of sampling. However, the many cases it is not economical or possible to do 100% inspection. So we can't cut entire watermelon, or we can't check every product is qualitative or not. So it's not. So if no cost, no, we need to consider the cost and labor cost, all those things. So for that, we are going with some portion of population. Okay, so here, for example, you can see live test of electronic components of our car crash test. Obviously, 100% inspection will be destroyed all products. So when inspection is necessary, 100% inspection is not possible. So we need to go with sample. So here, single sample plan. Sampling plan is a method of guiding and accepting sampling process. It specified the procedure for drawing sample to inspect from batch of products of and then the rule of deciding whether they accept or reject whole batch. So based on the result of inspection. No, as I told you, in sugar factory, so batch morning shift, evening shift, every 1 hour. So it will call as batch. So they are going to check the quality. If quality is not there, we are not sending to customer, because we send unqualitative product to customer. It's going to be damage to our any brand reputation. Now, olden days, we can see in Coca-Cola, we are seeing that lot of insects are there, or lot of rat will be there. No, some insects will be there. Such kind of things you may observe. No, they are not followed the qualitative thing. So finally, the unqualitative product lead to customer dissatisfaction. In corporate world, we'll call as in IT, each and every phase QA will be there. QA person, that is quality tester, will call as tester. Testing will be happen each and every phase of the project. So here, after result from the QA, that is tester, they are approving the process. Manager is going to be approve the process. That is how. So if developer did some mistake, again they need to rewrite the code for that. So because client satisfaction is very important for any IT industry. So customer satisfaction. So for IT companies, customer is nothing but their client. Satisfaction is very important. So here now we can see this is denoted as some formulas are there. The action of rejecting batch means accepting the consumption. This may include downgrading the batch or sell at lower price, returning to the supplier vendor. So suppose a sampling plan specified that small n, I already told you small n is nothing but sample size. N items are randomly. Randomly means random pick. So if have 1 to 100 numbers of products are there. So we'll pick randomly 100, 90th product randomly. So randomly batch of from sample. A. B is the batch, the reject if the product, if C or more those items are defects, non-conforming. So an operating characteristics. So curve will be there. OC curve. OC curve. Sampling define the plot probability that batch of OC curve. A sampling plan define the plot probability that batch. A larger is PA, that is P more likely to batch accepted. A higher likelihood batch is accepted. No, we can see that accepted and rejected. So accept quality level and reject quality level, AQL and RQL. In order to specify, that NC must be correctly defined. So NC, number of sample. What is member C here? See here, more items, the defective. Okay, so now you are going to see the fraction of defective level. So might be minute, namely accept quality level. If we collected sample size, no, out of 100, 10 or 20, or randomly we pick, and in that minute defection, fraction of defective levels, we can accept the quality level and rejection quality level values. So we need to AQL and RQ are two key parameters of frequency used to designing the sampling plan. An ideal sampling plan is regretted one of the accepted batch of 100% productivity. Now we'll go with the chart. Uh, chart. So an operating of characteristics of OC curve. OC means what? OC, operating characteristics curve. Operating characteristics curve of sampling. Now you can see here, you can observe OC curve. So probability of acceptance, if it is taken like zero product, it's like 100. So portion of defective. No, it's going to be increased. So portion of defective 0.5. So curve is going to be coming down, slowly coming down. Here we are rejecting the curve, not accepting the curve. Now for this, no, I am going to draw one kind of chart here. Chart here. Okay, now I'm going to draw something like now you can imagine this is the thing. So if products are 0, okay, like 5, some interval like 10. Now, so if it is 0, it's going to be 100%. So if products are increasing, defects are increasing at this time, we are going to reject the thing. Here rejection is going to be happen. Rejection is going to be happen. So this is how we are going to state this. Okay. Right. Okay. Now, so double sampling plan. What is meant by double sampling plan? Sometimes situation arises when not possible to decide whether accept or reject the lot. So based on single sample, in such situations, we use sampling plan known as double sampling plan. The name itself indicating that first single sample is not giving any kind of accept or reject result. So we'll go with another type of sample. Again, we are going to take sample. So this plan decide the decision of accept or reject of a lot is taken basis of two sample. A lot may be accepted immediately. First sample is good, maybe rejected if it is bad. So first sample is neither good or bad. So decision based on the evidence of the first and second sample combined. So what happened? We are taking first sample, and no, first we'll take sample size of 100, 100 out of 10,000. So we'll test. And so no, they are not quality manager is not satisfied with that sample. Okay, in manufacturing company. So what they'll go with? They'll go with second sample. They'll take second sample. So in second sample, like they'll go with maybe equal or increasing the size. It's up to their wish. Now here you can see this, the draw two sample of 10 first time and 20 second time and accepting the number for the plan 1 and 3. So first time 10 sample they taken, second time 20. 10, that is 10%. Okay, 20, that is more than 10%. So the buyer takes the two sample, make decision of accepted, rejected. So based off two samples, since the decision is accepted, rejected. Now here, in this, we have N1. N1 is nothing but sample size of first sample. So N, already I denoted, N is sample size. No problem. So N, any issue? Okay, please. Thank you, sir. Okay, so N is the small n is denote the sample size. So here N1 denote the first sample. C is nothing but acceptance of number of first sample. So C1, C is the nothing but acceptance. N again N2. So second sample. And C2, acceptance number of both sample combined. So therefore, the parameter of double sampling, the plan in the above example. So here, N1, already we told you 10, and C1 is 1. N2, that is sample is 20. C2 is 3, acceptance. Now, for this, we are going to form one kind of steps to implementing the okay. So, for example, lot size, okay, say capital N. Capital N is nothing but total population. Capital N is nothing but total population or received from the supplier or final assembly line and submitted for inspection one at a time. The producer of implementing the double sampling plan to arrive at decision about lot described in the following. No, you can see draw random sampling. Okay, that is we need to define N1. So here N1 size is 10. Lot received from the supplier or final assembly. So it might be anywhere. So second step here is we inspect. So N1, the sample of 1, we are going to inspect every unit of the sample, classify it is as defective or non-defective at the end of the inspection. Then we are going to count the defective units found, and sample supposed to be number of defective found in first sample is D1. In first sample, it's like D1. 1 second. Hello? Karnool. Hello? Okay. So sorry for the disturbance and 1 second. So here defectives D1 and we compare the number of defective units D1 found in first sample with C1 and C2. Then we'll take the decision based on first sample follows. Under this circumstances, sample if number of defective units is D1 and first sample less than or equivalent status says. Okay, we have seen first N1, C1, D1 defectives. Now you can see one logic we will apply here. So D1 is less than or equal to C1. We accept the lot. If D1 is greater than C2, we reject the lot. But C1, D1 and greater than first, we can see C1, D1, C2. The relationship between C, D, again, first C1 and D1 and C2, we are going to take some necessary action. First single sample is failed under this rejecting sampling plan. So, and D1 and C1, if greater than or equal to, we accept replace the defective units found in the simple sample by non-defective units. If D1 greater than C2, we accept the lot inspection, either lot replacing defective units. Now, so the relationship between here, the relationship between D1, first C1, D1 and C2, then D2 picture is going to be coming. D2. Now, it is a permutation and combination of, it's a permutation and combination of this C1, will change the color. Okay. No, it's changing entire thing. So the permutation and combination of C1, okay, then D1 will change the color here. And then C2, one more thing, C2. Then we'll change the color here. Again, we'll go with another color. And finally, D2. So we have the some permutation and combination. So if C is greater than or less than or equal to, so we are going to accept and reject the things. Okay. So step 5, if C1, D1 are greater than or equal to C2, we draw second random sample N2. If C1, D1, C2, we draw the second sample of N2 from the lot. Then we are going with N2 lot. We inspect and each and every unit of second sample and count the number of defective units found in it. So suppose the number of defects units found in the second sample is D2. Then what is the relation? We combine and D1, D2, we are combining defects and C1 and C2. Right, sample 1 and sample 2 and defective 1, defective 2. So we are combine the number of defectives, What we are going to do here? So here we are combine the defective units D1 and D2 and found in the both sample, consider D1 plus D2 for taking decision about a lot on the basis of second sample found follows. Under the circumstances, under this acceptance of D1 plus D2 less than or equal to C2, we accept the lot. And D1 and plus D2 is greater than C2, we reject the lot. That's it. So under rectifying sample, D1 plus D2 less than, we accept the lot and replace the defective units found in second sample by non-defective things. So this is how formula is there. Now we are going to see in one chart manner. First, select the first sample of N1. Okay, count the number of defective D1 during time period of T. So if it is only first case, D1 less than C1, accept the law. If it is C1, D1, C2, so select the second sample in simplified manner. Select the sample N2 and count the number of defect D2. So here defective 2 is come to the picture. Again, we need to count D1 plus D2 and the count is less than equal to C2, accept the lot. If count is greater than C2, we can reject the lot. And finally, we'll have D1 greater than C2, we can reject the lot. So this is a simple manner, better of understanding. Okay, you can see here in pictorial manner, you can see D1, C1, okay, the relationship. Have any questions here? Hello?
No, sir.
It's clear. Okay, fine.
It's clear.
Okay. Now we'll take example. We can say mobile phone company produced mobile phones of 400 phones each. Okay, one lot in lot. So check the quality of lots. The quality inspects the company used double sampling plan. N1 is 15, C1 is 1, N2 is 30, C2 is 3. Here explain the following procedure to implement. So here we will have D1. So here out of 15 mobiles, first sample defective or non-defective. So here at the end of the inspection, the number of defective D1 founded in the first compared with C1 D1. So if the D1 less than or equal to C1 is equals to 1, then accept the lot. If D1 is greater than or greater than C2, that is equal to C, reject the lot. So C1 less than or equal to D1 less than or Okay, 2 or 3. So that's how it's going to be calculated. So what is the advantages? I think the principle of advantage of double sampling over the single sampling plan, the same degree of production. So whenever we are going with first quality, first test and second test, there is the advantages there for no company only. So why they are going with this kind of things? In order to satisfy the customer satisfaction. So sometimes even first time randomly we pick right. Random pick whenever we are picking the random, not total sample, only portion of sample we are going to pick. So there might be or might not be. Chances are no, our no products are qualitative. So for that, they are going with D2. No, some cost wise, they are going to reduce. So what is meant by single sampling and double sampling? So you know that single sampling plans are easier to design and operate the comparison, but double sampling is somewhat compared with expensive wise. And we need to compare between two, first sample and second sample. So it incur cost, not only cost, it takes some time to check the quality. But in single sample, probability of defects are very high, and double sampling probability of defects are very low. So these are the some difference between okay single and double sampling. And next, sequel sampling. Another part is sequel. What is meant by sequel? Okay. Uh, No, sequel 1, 2, 3, 4, like this. So sequel. Sequel is multiple sampling plan where a number of sample units drawn depend on the results of inspection of sample drawn. It involves a sequential inspection of units or group of units from chosen a lot of random number after inspecting unit. So here a lot is accepted, the lot is rejected, the evidence is not sufficient, either accept or reject. So if you see double sampling, first lot is accepted, second lot is rejected. So what happened? They'll go with third sequel. In case of third opinion, in doctor case, we are going with one disease, they suspected one disease, they'll take second opinion. You take another doctor opinion. Okay, second, first doctor, they'll say, okay, some X person is having disease, that particular XYZ disease, its symptoms are like that. They'll go with second opinion. The second doctor say, no, 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 you don't have any disease. Then they'll go with third advice. It's happened. Same kind of thing. So sequel means 1, 2, 3. First will go with sample, accepted. Second, they're going to be rejected. Then they'll go with the third opinion. So that is called sequel. A group of unit inspected. That's the three or four set discussion considered the combination of. So here advantage of sequel. The main advantage of sequel is sampling over other sample inspection is that average number of unit is inspected under the plan is lesser the single and double plan. So disadvantage is nothing but it cost. So we require inspection record, calculate the inspection of unit and each unit, the processor proceeding further. So here cost. So these are the sampling methods: single sampling, double sampling, sequel sampling. Okay, fine. So this is how you are going to do. So in this unit, we are going to have any questions related to this unit. It's clear, right? Okay. Now we are moved together. Once again, where we are moving ahead. Now, next unit is like statistical control, quality control. So here, statistical quality control. So in this uh, chapter, we are identifying variation. We are going to study the in-depth of variation and control charts. We are going to see, and X bar and R we are going to see. So this is how the structure, the function of quality control, responsibility towards quality control through standardization, variation in quality, need for control charts and types of limits, and quality control, statistical quality control, construction of quality control, characteristics of control, types of control charts, and control for variance and construction of mean, median, mid-range, and the charts, and estimation of X and X bar and R charts. We'll see. So what is meant by quality control? So what is exactly quality control? Any idea? Why we need to go with that? Any idea? Quality control. Why we need to control the quality, statistical quality control? Any idea? So let me give example. If we are supposed to construct a building. If we are going to construct a building, in building shape wise, if you paint the building, its appearance wise, it's quite good. But so during the rain time, during the sun, during the wind time, okay, what happened? So for that's just 30 kilometers wind is happened, the building is going to be collapsed. Like 10 no, rainfall is happened continuously, building is going to be collapsed. Or heavy heat waves are happened, building is going to be cracked. So what exactly the ingredients, that the parts, components, I can say components used to construct the building is not qualitative. Final outcome is building one house or a building or a road. So what are the material they used for that? Raw material used for that is not qualitative one. Then the impact is going to be happen to end user. So quality control is involves establishment of quality standards, use of proper material, selection of appropriate manufacturing process, and necessary tools to make the product quality to product and perform the necessary manufacturing operation. Today we are eating some kind of foods, junk foods, or else like Haldirams, I can say. If Haldirams, they need to select the right kind of raw material, whatever, we can say peanuts. So we'll call as in peanuts. In local language, palli or something. So in peanuts, if you say kazu, they're given fries. So if they are not taken proper kazu or proper peanuts, the size wise, quality wise, weight wise, they are not processed, then it impact on, they prepare that no like peanuts, masala peanuts, salted peanuts, and they prepare it, and they're selling the customer. At the end of the end user customer, they feel that this product is not up to the mark. The finally what happened, they are losing their business. Understood? That's why the quality control plays a very vital role in any organization. Okay, so what they're going to do, they're going to be filtered that no peanuts. There are different sizes of peanuts are there. For equal size, they'll filter with some kind of filters. So they'll keep that whole processed, small peanuts, they are going to be filtered. Large peanuts going to be happen in that particular tray only. So only particular size, standardized size peanuts only, they are going to be filtered, and they are going to use for the process of like peanuts, masala, whatever it may be. Similarly, kazu also, there is a process. So here, what happened? The systematic control, those variable encountered a manufacturing process, which affects the excellence of end products, such as variables, results, application, material, men, machine, manufacturing, four ends, material, men, machine, manufacturing conditions. So this is the basis of the purpose of the production process. Check the control, the quality of the product while manufacturing progress. Now here, the process of need to meet the quality standards to use the product already laid down. This process comes across the different types of control charts. Name the control charts are variables. Control charts are attributes as discussed. No, already we discussed in unit 3. And variables measured means the average is mean, range, standard deviation, corresponding control, X bar and R and sigma charts. So here, so functions. What are the functions of quality control? So why we are going to go with design a product or service in such a way that it means customers requirement. That's very important. Customer requirement. So why now if you see the AC, how they are going to build the ACs? Earlier ACs they are fitted to door ACs. Now outdoor fit will be there. Now they are we coming with like oxygen filtered, oxygen layer. Sometimes, even 60 degrees also our AC will give cool. It's going to be cool. Similarly, mobile phones, you can see the lot of features. If go back to 20 years back, even the starting classes I discussed about mobile. 20 years back in 2000 range, 2000, 2002. No, mobile means wireless phone. So it's very expensive. Now its generation is there 1G, 2G, 3G, 4G, 5G. Now we are into 5G mobile. 5G mobile generations. And if generation is changes, lot of revolutions they are coming to picture. If I'm not wrong, you people might be seen or not. There is a alarm clock. Alarm clock is there each and every home. So it shows we are used to give 3:30 alarm. They'll give ting 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 sound like that. Okay, so alarming sounds. Now, you can't find many houses with alarm clocks. Reason is the customers are advanced. They want advanced features. Earlier, we have like no film-based cameras. Now that is replaced. Now the mobile revolution, due to mobile revolution, it's gone. Okay, quality. So first thing, the use of substandards material or components might be affect the quality the product, and hence the quality control personnel should be they purchase material and part of the component or etc. for standard accounting. Identify and improving the information on cause variation in production process so that corrective action taken. See that the product produced, product serviced safety conditions. So safety is also very important role. Use of electrical and electronic peripheral devices. Now safety means that the product should be a shock proof, and will call as radiation free, eye free, safety. Lot of safety. The provide the satisfactory product services, that is after sales and services. Already we discussed the employee quality conscious fixing their responsibility variation of the stage production. The prevent rather than detect defective items to be produced. So after distribution of the products, after distribution of the product, if they found defective, instead of that, before going to no customer hand, we can found the defects. There are lot of things are there. Lot of things are there. One second. Lot of things are there. So where we can do some kind of defects. So have you heard about buybacks of the cars? Buybacks of the cars. Yes or no? Buybacks of the cars. Any item is going to be returned. Have you heard about this?
No, sir.
Okay. So, okay, I am going to give you an example. Returned back.
I heard it, sir.
Yes, please.
Yeah, it is there. Yeah, it is there. In IKEA, we have a buyback 90 days.
Sorry?
In IKEA, we have a 90 days buyback products. On the
Okay.
articles, it can be anything you
Okay.
can purchase, but few articles are not returnable,
Uh-huh.
like live plants or the cut pieces, cloths, or uh, open
Uh-huh.
matrix, or like that.
Uh-huh.
But
Okay.
remaining all buyback is there. Means
Mhm.
if it is a customer doesn't like, they can come and return it. So we take it back and we refund the amount.
Mhm. We'll call as recall.
That
Recalls.
is, recall is different, and this is called the customer change of mind.
Correct. Correct. Correct.
Hmm.
So because they found that quality problem in their products or service, they'll recall the products.
That is
Okay.
comes under the quality assurance. That is a recall, and
Exactly. Exactly.
this
Exactly.
one
So because of the quality is failed, the quality is failed, then they're going for recall. Most of the students you might be aware about this. Okay. So I'm going to give one case. Toyota recall their cars. You know that? Just you can Google it. I think 19,000 certain vehicles, ES, LC, ES models, they recalled in USA, Toyota, due to their product problem, that's quality problem, like that. So here, why this kind of quality control? If quality control is good, no need to call recall of the products, because there are certain standards are there. Once you are not faced that certain standards, they'll recall the products. Even medicine also, they are going to be banned because of poor quality control and the mixture of drugs used in that particular brand. That's also one of the cause. So the at the production stage, the inspection is work and services while being delivered. So here, these are the things. Then responsible towards quality control. So who is responsible for that? First factor is engineering. Engineering deals with creation of development of product. So certain concepts, quality evaluation, identifying cause and defect, and rectifying the substandard products. Then statistics. Statistical knowledge build the information which applies the quality techniques to determine how far the product conform to the standard quality and precisions. And then managerial, the techniques engineering and statistical have to be integrated by policies, practices, management. It management who create the nurtures the quality conscious climate organization. So these are the things. And quality control through standardization. What is meant by standardization? Anybody knows standardization? Standard. What is meant by standardization? What is meant by standard? Hmm. Anything? Any guess? Will use no. Our product is standard product. This bridge is very standard. Standardization is nothing but benchmarking. What is meant by that? Standardization is nothing but setting up some rules and regulations and some guidance throughout the process, or I can say it's like instructions given to that. So here, standardization, it's related to time, material, performed, and reliability operation at any qualifiable characteristics of product. So quality control reliability in product can be achieved through adequate system and standardization. Proper standard can be developed and applied at every stage product production process, such as design, raw and in progress, material selection, control, process control, tooling, production methods, techniques, inspection, etc. Some different standards are developed effective quality control. So here, preparing technical specification. They need to prepare some technology like standard specification of variation. No, in procurement, procurement of raw material, they'll go with some kind of rules and regulations. And engineering, design and specifications, manufacturing specification, administrative specifications, test specification, product specifications. So these are the preparation of technical specifications. So they are going with some kind of standards. So I want the product of this grade product only we can accept. Otherwise, we can't accept. If you take example related to this, one like coal-based thermal power, they want grade 1 coal only. We use only grade 1. Even you can see some kind of hotels, they mention that we use only refined sunflower oil. We used to cook only on purified water. Have seen that marking. So some hotels they mentioned, like restaurant, we used to cook only one time oil. Second times they can't use. Such kind of standards they are maintaining. Okay. So even oil also, there are a lot of oils are there. We used to cook only refined sunflower oil, refined groundnut oil, refined palm oil. We used like this. Some cases they use dalda, or some cases like that. So this is called specifications. Next, after that, preparation of standardized procedures and equipment used for inspection of testing. So they used to standard to be procedure tools. What are the things? Next, standard manufacturing process and method of tooling. What are the method tools they are used? And preparation of codes to practice to be used in guiding during manufacturing. So here they give some kind of instruction during instruction displays they kept in during manufacturing units. So don't use your hands directly. Use gloves. Use helmet. Okay. If you go to if you go with chocolate kind of manufacturing, so they'll give you gloves, and you need to cover entire hair. So even if woman is working, they won't allow to even no, they should cover with entire head with no hair with no cap. They don't allow with flowers, because a small hair fall in chocolate, it lead to customer damage. It's a process. Some restaurants, if you see the restaurants, all restaurants, no, they used to follow this kind of thing. They'll cover their hair, because sometimes we don't know, hair fall will be there. All of a sudden, hair is going to be fallen. If it is fallen ground, no problem. If it is fallen in food, then problem is arises. Okay. So because of it, this is standardization. So preparing codes, the preparation of standard types and design for final product. So here, engineering products are always possible to standardize design and product national or group level. This standardization help to reducing the variety of component and finalizing the interchangeability of parts and within the things. See, standard can be developed various level. So standards, one is company level, group level, national level, international level. Company level is nothing but okay. So company level is nothing but within that company people, they are going to group of people, the standards. Okay. Together society. The national level is nothing but standards, like they are giving agmark symbols and silk mark symbols and some kind of symbols will be there. The national level. International level is nothing but standardization is nothing but ISO, International Standard Organization. So there are certain standards are there, international level. So they are going to get kind of ISI certification, ADMARC signal, silk mark, and a KDM symbol at national level. So if you go with the international level, we'll follow international standard organizations. So there are some certain specifications are there. So like technical specification, performance specifications, and like brand name. So these are the things. What is my technical specification? Physical channel proper design product and dimensions of specification, desired proportions measures. And performance means performance is nothing but customers interested in the performance of the product and not in detailed technical analysis. Hence, the product performance specification are developed to indicate the needs to customers that manufacturing product or perform the explanation of the customers. Performance specification describe the performance. So here, brand is nothing but they are talking about name. So Airtel brand, like we have international brands like Puma is international brand, Nike is international brand. So brand. Now here variation in quality. Variation is nothing but difference in quality. So maybe Chinese people they'll follow this kind of thing. You know, we'll call China. I'm not talking about China. China is having the mass producing of all kind of industrial related products. China, what they'll do based on the budget, they give the quality to products. You go to America, in America, 50% of the market share occupied with Chinese items. Okay, that's why they are becoming world number one. Manufacturing of any products manufacturing, because they can duplicate anything, and they'll reproduce the products. Earlier, we have seen in childhood days, China Bazaar. In China Bazaar, we'll get all Chinese products at cheaper rate. Starts from toys to, like thousands of worth products. Okay, so this is a variation of quality depends on the quality need for charts. So why we need to go with charts? So charts, so minimum scrap will be there, rework and lesser work, and reduce the cost of material and reduce the variability, uniformity, quality, reliability. Next, it gives to sales, increase the sales turnover, reduce the inspection cost, reduce customer compliance, and better utilization of resources, higher up to no types of limits and control limits and specification limit and tolerance limit. What is mean by control limit? Limit is sample of variation of statistics like mean, range, fraction of defectives. So this control under the control characteristics measures and calculated from different samples will within these limits. So specification limits are the values between which product and services should operate. These limits are usually set by customers' requirement. The produced will be realized for the purpose of intended to use dimensions. So tolerance limit variation is quality of measures of production between which at least specification of proportion of a product and accepted for this. Next, statistical quality control. So SQC is application of statistical techniques determine whether manufactured produce conform the quality standards or not. So here, what happened, the manufacturing produce of uniformed acceptance quality, uniformed, so this, they're used like automobiles and electronic and electrical items, pharmaceutical SQC they are going to use. Now here there are techniques are there, inspection method which furnish classified sample into inspection, then statistical control that implemented by method, the control charts and automated control. Now SQC techniques, now process control, product control. So in that process control, there are two types, variables, attributes. In last class, we have seen variable, what is meant by variable, what is meant by attribute. So here variables mean range, standard deviation charts, and attributes is nothing but P, NP and C chart, and product control variable and attributes, they are going to be there. Now, a manufacturer said to be under control, this operation factor. So you'll see. So how we can construction of charts. So quality scales, plotted samples, and these horizontal lines. So here, we'll see they'll have the limits, upper limit control chart, upper limit control, center line, and lower line control. So here upper limit, center line, lower limit control. So there are three components are there. Control chart. So characteristics of control chart. There are a lot of characteristics. Point inside and outside, points outside, change or jump in level, trend and steady chance of level, and recurring cycle. So types of control charts. Control charts are variable X bar chart, R chart, and sigma charts. So control charts per variable, we'll see here. Now you can see construction of X bar chart. So mu and sigma are given. So CL is equals to mu. UCL, upper control chart X, is equals to mu by 3 sigma divided by square root of small n. That is the sample size. Okay. Then we'll see this in next class. So we'll see in next class, or else if you have time, then I'll complete this unit. Shall I continue now for 5 minutes? If yes, then I'll continue. There is no response. I'll continue this in next class, because 12:30. It's almost 12:30. There is no response from your end. Hello.
Sir, you can continue, sir.
Okay, fine.
Yeah.
Thank you. Right. Now, see here, upper control chart, lower control charts are there. Now we have upper control chart, lower control chart, 3 sigma divided by square root of n. So we have addition to control warning limits are there. So upper warning limit is mu plus that is determined 1.996 sigma distance can be shown in X bar chart. So similar lower chart. So we can see one example related to this. The production firm and a process of said the under control if diameters have the mean of 3.5 inches. Standard deviation is that is 0. No, standard deviation is 0.05 inches. Construct a control chart of the mean random sample 10 A 10 B 20. So now you can see when n is equals to 10 here, n is equals to 10. So here mu is equals to 3.5 and sigma is equals to standard deviation. So standard deviation is equals to 0.5 inches. N is equals to 10. Then center line, that is CL, 3.5 inches. Upper control limit is equals to 3.5 plus 3 into, no, standard deviation. What is the standard deviation here? I'll write here. 1 second. I'll write here. No. What is the standard deviation? No. Here, mu. Okay, in my keyboard, mu is not there. Mu is equals to what is the mu value? 3.5.
3.5 inches.
Okay, so standard deviation is equals to like
0.05.
0.05. Okay, so these are the given. So n in small n is equals to 10. So these are the values they given. Now here, when n is equals to 10, then central line. What is the central line here? Central line here. Okay. Central line here, 3.5 already given in the thing. Then upper central line at upper central limit. So here UCL is equals to 3.5 central line for 3.5 plus 3 into why 3 into standard deviation into standard deviation. Standard deviation is 0.05. Okay, I use brackets here like this, otherwise you're getting confused. Okay, into sample here is square root of square root of 10. We'll calculate it, we'll get some kind of value that is 0.047, and that is equals to upper limit is 3.547 inches. Okay. Similarly, we need to perform. We need to perform. Okay, we need to perform lower limits. Upper limit we have seen. Lower limit we need to. So we need to do some kind of lower limits, lower control limits. Same. Now plus is coming for upper limit, upper control limit. Lower control limit is minus. That is equals to 3.453 inches. Upper warning limit, we need to add 1.96. Already they given in the data. So this is warning limit. Lower warning limit is also there given. So this is the one sample size of 10 we are going to calculate, and sample size of 20 we are going to calculate. Same kind of thing. So 20 instead of 10 square root will be there. We are going to calculate it. So here for sample limit, now we are going with the control chart. So 3.55 is the upper control limit, and 3.53 is the upper warning limit, and 3.45 is the central line. 3.47 is the lower warning limit. 3.45 is the lower control limit. Simple. You got it? Similarly, when sample size sample size is going with 10, what happened? You can see here 3.43 and the sample size 20. Same kind of thing. It's A and it's B. I think it's by mistake it given n is equals to 20 here. Okay. N is equals to 20 here. Now you can see when is equals to 3.534, 3.534, 534 in between 3 to 5. Okay, n is equals to 20. I think it's printing mistake, it seems. Now here, it's clear that mu and standard deviations are controlled warning limit depend on the sample size. As sample size increases, the control become closer. So when sample size is closer is broaden. Sample size increases, it's going to be closer. Central line, it makes the chart are more sensitive to small variation process average. Now, construction of R chart. So R chart is D2 into standard deviation. Upper CL, lower CL, upper control line and lower control line of R. Earlier it is X. You can see X bar. R bar. Now here R. For example, same thing. So when draw same when n is equals to 10, D2 is equals to 0.3078 and D3 is equals to 0.93. So now CL is equals to this 0.078 into 0.05, that is the amount will came. So we are going to calculate same thing. R chart will be there. Okay. And so with this, today's class, I'm going to stop here. We'll continue in next class. Have any questions, please? I'm going to clarify now. Have any questions? I'm going to clarify now. Hoping nobody's having the questions, right? Hoping so. Okay, then there is no questions. And then we'll call for the day. Okay, thank you so much. I think somebody is speaking.
No, sir. Thank you, sir.
Thank you. Thank you. We'll see in next class. Thank you. Sir, Ambedkar team It's over to you, sir. Thank you. Please stop recording. I think somebody's